Problem 4 is about differential equations. We don't ask for solving these differential equations because solving them is rather hard. It uses methods which we have not yet seen, but we basically just ask to verify solutions of a differential equation. The only extra work is that we don't ask you verify this solution, but to check which of given functions is a solution of a set of differential equations. So how do we do this? Basically, for each function we calculate, say, dy over dx plus 3y, and we compare, is this equal to e to the x? Is it equal to e to the minus x? If yes, it's the first or the third solution. We also calculate dy dx plus e to the x, and we check, is it equal to x squared? And if so, it's the second solution. And we do this until we get a match. What we need is simply to calculate derivatives. Okay, there was already a hint given in the exam that the first function can be simplified. Now let's calculate the derivative for this function. We get that y1 prime of x is using the standard derivative rules. By similar arguments for the other functions we get the following derivatives. So we get these four derivatives for our four functions. Now let's calculate. What is y1 prime of x plus 3 times y1 of x? This is equal to, we see that this term and this term cancel, and the minus 1/2 cancels with the plus 3/2 to a factor 1, so we get e to the minus x. Having seen that this is e to the minus x, we observe this is the solution of the third equation, so function 1 is a solution to the third differential equation. Now let's do the same with function 2. Again, this term and this term cancel out. The 1 over 4 e to the x plus 3 over 4 e to the x gives us e to the x. So we see that the second function fulfills the first differential equation. Now we need to look at the second differential equation. Y prime plus e to the x is equal to x squared. So we need to evaluate y prime plus e to the x for the third and the fourth function. So let's calculate y3 prime of x plus e to the x. If we compare with the second differential equation, this is certainly not x squared, so y3 is not the solution. So let's do the same thing for y4 the x, which is equal to x squared, so y4 prime fulfills the second differential equation. Now we need to also solve the initial value problems. We need to find the right value of c, which gives us this initial value. How do we do this? We simply set, since we have initial values at 0, we simply set x equals 0 for the functions one by one, and we then check for what value of c we get the right value. Okay, let's get this started. And we have function number 2. So if we look at y2 of 0, saying that e to the 0 is 1, 1/4 plus c. And what we want is that is should be equal to 0. That's what we demand. That's our initial value condition here, that this is equal to 0. So we get that c must be equal to minus 1 over 4. Next to function 4, equal to minus 1 plus c, we want this to be equal to 2, because that's what our initial value condition demands. So we need that c must be equal to 3. Finally, function 1 is 1/2 plus c. We want this to be equal to 3/2. So what we need is that c needs to